What's up, guys? It's me, Sir Ernest, and today we're going to answer problem 7.1 of Fowles and Cassiday 7th edition. The problem reads, a system consists of three particles, each of unit mass, with position and velocity vectors as follows. Find the position and velocity of the center of mass, and find also the linear momentum of the system. Okay, so we already know that these are the position of each of the particles. This is the mass of each of the particles. We take note that m1 is equal to m2 is equal to m3, and that is equal to 1 unit mass. Okay, so therefore the position of the center of mass will be equal to 1 over capital M times sum of mi ri from I equal to 1 to 3. So this is just a direct application of the equation. So because m1, m2, and m3 are all equal to 1, so therefore the total mass m will be equal to 3. So this is equal to 1 over 3 times m1, so that's 1 times r1 plus r2 plus r3, because remember m1, m2, and m3 are all equal to 1. So therefore this is equal to 1 over 3 r1, so we just add this 3, taking note of addition by through addition of vectors by their components. So this means this sum will now be equal to I hat plus j, so that's 2j hat plus k, so that's 2k hat. So this is now the position of the center of mass. The velocity of the center of mass, while it's true that you take the time derivative, you can take the time derivative of your position function, but right now we cannot do that because this is a constant in t. However, we're given with the instantaneous velocity of each of the particle. So that means we can take the time derivative of rcm, which is 1/3, times the derivative of r1 with respect to time plus derivative of r2 with respect to time plus derivative of r3 with respect to time. This is equal to 1/3 times v1. This is v1, this is v2, and this is v3. Okay, so taking the sum of v1, v2, and v3, we now have 1/3 times 2i plus I, that's 3i, plus j, 2j, then plus k. So this is now the velocity of the center of mass. Okay, so finally, in the linear momentum of the system of particle can be computed as the sum of the linear momentum of each of the particles, and this is equal to sum of mi vi, because each m is equal to 1, so this is sum of v1, so this is v1 plus v2 plus v3. Again, don't forget the sign, vector sign, the arrow sign, indicating that these are vectors. So again, adding this together, we now have 3i plus 2j plus k hats. So this is derived by calculating first the individual momentum or linear momentum of each of these particles. However, as previously discussed, the total linear momentum of a system of particles can also be expressed in terms of the total mass of the system times the velocity of the center mass. So we know from our previous result that m is equal to 3, and then the velocity of the center mass is 1/3 times 3i plus 2j plus k, which is equal to 3i plus 2j hat plus k hat, which is exactly the same as our previous result. Okay, so that's it. That's problem 7.1 of Fowles and Cassiday 7th edition. I hope you learned something today, and I'll see you guys in the next video. Bye-bye.